Hi everyone, thanks for joining us at the Things virtual conference. We're introducing a quite unusual LoRaWAN use case today, and we're very happy that you're joining us. I'm Elisabeth, I'm the founder of ECBM, and we are what we would like to call a digital problem solver. That means we provide complete digital solutions for real-world problems, and for IoT, one of the main technologies that we use is LoRaWAN. It has a lot of advantages for availability at hard-to-reach areas, where you can't have power and where you need to be quite far away from where the data actually has to come in the end. And one of the more unusual use cases that we have for LoRaWAN is actually vibration measurement. Our customer is called Infraserv, and they are a very large chemical park infrastructure company. So they run three of the largest chemical parks in Germany. And they have a lot of equipment that they are actually responsible. They do all the stuff with infrastructure that the actual chemical companies don't want to do. So they run a lot of the buildings, a lot of the machinery, all the logistics, the canteen, and everything that's infrastructure related. So the customer would like to know that things are not in perfect condition before they actually break. And in a production environment, in a motor environment, measuring vibration is a very good measurement of the actual machine condition. Because most motors and most machines have like a normal vibration level. And when you get a lot of deviations from normal, and you even get a trend of the deviation from normal, that means that something is not quite as it should be. However, vibration is usually measured on a continuous basis, which makes it a not ideal case for LoRaWAN, because in LoRaWAN you cannot transmit on an ongoing basis. So we had to find a different solution. This, my friend Bob. Hi Bob. This is part of the solution. Bob is a vibration sensor that actually has some intelligence on it. You put it on a machine, it learns for a week what the normal vibration level of the machine is, and then it constantly analyzes the vibration level of the machine. And only when there's an anomaly, so deviation from its normal vibration range, will Bob send an alarm. It also sends like a report every 3 hours about what's going on, but the alarm is the really important thing. It sends what has happened, what the anomaly level was like, what the top frequency was, vibration frequency that was going on at the time, and some more information about what happened when the anomaly happened in the sensor. And this data we then put on a dashboard, and we show our customer what actually happened, and we show them trends over time. Trends over time are super important to see in which areas actually you have normal situation, in which area you get constant alarms, and whether there's an upwards or downwards trend. This will allow you to predict when machines might fail in the future before they actually do. And like that, you can avoid these super expensive and dangerous situations. Our customer is totally excited about this and has given us some more information, some more data from their actual production processes. So now not only do we know the vibration of the machines, we also know the power level under which they are being run. So are they being run like on top power all the time, or somebody being a little bit more sensible with them? And we can see the connection between the information from the sensors and the actual production processing data, and find some correlations between this. For this, we've built an AI algorithm which is analyzing this data on an ongoing basis. So our customer is super happy with us, and we've started a lot more LoRaWAN use cases with this customer, and we hope to continue working with these guys for a very long time. If you have any questions about this, please let us know. Just get in touch. Thank you very much for listening.